All right, welcome everyone, and thanks for joining this SCOMathon session. This one is about inside the SCOM health check, what we see, what breaks, and how to fix it. I am Bob Cornelissen, a 16 times Microsoft MVP from the Netherlands and leader of the Topcore and Innovized companies. I've been working with SCOM for 25 years now, and I have here my colleague Ali. Can you quickly introduce yourself?
Hi all, welcome. I am Ali Burak Genç, colleague of Bob, meaning I'm also working in Topcore since 2024 as a consultant, and this is the second year in a row I'm here in Scomathon as a presenter.
Ooh, today we will take you inside what we actually see during real SCOM health checks. Not in theory, but the patterns that repeat again and again in customer environments. We are grounded in field experience and best practices, and we will explicitly connect everything that we discuss to symptoms that you have already recognized. Slow consoles, alerts arriving late, grooming that never really finishes, operators slowly losing trust in what SCOM tells them. And that loss of trust is important. When monitoring feels unreliable, teams stop acting on it. And then problems slip through. Everything we'll show today comes from health checks that we've actually run across many different companies over the many years. The goal is not to overwhelm you with details, but to help you recognize patterns. When a symptom sounds familiar, that's your signal that the underlying cause probably is too.
Yes, to give you the storyline of this session, first we will explain how we approach a health check, then we move through the SCOM stack in the order that actually matters, starting with design, management servers, the SQL backend, gateways, agents, and then moving to management packs, and finally understanding. And the order is deliberate. As we move through the slides, notice how the same root causes keeps showing up just with different faces. That's why fixing things in the right sequence eliminates multiple problems at the same time.
So let's start with the question, why do we run health checks? Health checks often start with a vague feeling, something isn't right. Performance is degrading, alerts are delayed, troubleshooting is needed and takes longer, and sometimes it is about an organization asking us to check their configuration for one of the reasons listed here, or for compliance reasons, or just to feel at ease. Also, we run these checks when for an upcoming upgrade or migration, and suddenly everyone is nervous, right? Our goal is to turn that feeling into evidence. So you know what to fix first and how to justify it. We also run these while doing migrations and right after as part of our checks if we missed anything, and also as a handover documentation and a few to-do steps for later that make the monitoring even more mature.
We most often run the SCOM health check because it has a high technical part. We also sometimes get asked to run a SCOM audit where we look at processes, procedures, documentation, and stakeholders. During a health check, we validate configuration correctness, performance bottlenecks, stability risks, and readiness for change. Even when no upgrade is planned, the same issue almost always blocks future projects. Addressing them early saves a lot of pain in the future. When environments environments are struggling, the symptoms are very consistent. Slow consoles, intermittent gray agents, alerts arriving late, and people compensating by restarting services or adding overrides. What is important is that these symptoms almost never exist alone. They are downstream effects of a smaller number of root causes, usually starting at the data layer and then amplifying outward.
So that is why our approach is always left to right through the SCOM pipeline. We measure first, we change one thing, we measure again. That discipline is what separates guesswork from engineering. So before talking about fixes, we need to understand the patterns. SCOM environments rarely break in surprising ways. They usually break for predictable reasons. And that is actually good news because predictable problems have repeatable fixes. So let us have a look at a few of these. So design is where most environments quietly accumulate technical debt. Sometimes it is because the original design did not take into account the number and types of objects in the monitoring. We've also seen designs and backend setups based on wrong assumptions of how the product actually works. Most SCOM environments start simple. A few management servers, a SQL backend, maybe a gateway or two, and that design works initially.
Yeah, the problem is that environments evolve incrementally. New workloads are added, new locations come online, security requirements change, high availability is added, but the original assumptions are not re-evaluated. One very common pattern we see is high availability being added on top of an existing design without validating quorum, latency, or workload distribution. On paper, the environment looks resilient. Operationally, it becomes fragile. And design issues rarely show up as hard failures. They show up as small delays, inconsistent behavior, and an overall sense that SCOM feels unreliable.
Yes, one of the common design and practical things that people underestimate is when there are a number of locations or data centers involved. Some organizations have everything in one data center, or maybe in two very highly connected ones, but others simply have a lot of locations due to how their business is set up. These are things that we also discussed during our advanced designs training, by the way.
So, this slide is about growth. SCOM is extremely scalable, but only if sizing grows with reality. We frequently see environments where agent counts doubled, Linux monitoring added, network monitoring also come into play, and maybe VMware as well, but the management server counts stay the same. SCOM doesn't scream when that happens. Instead, it degrades gracefully. Queues grow slowly, workflows take longer, operators feel it long before alerts fire.
And aside from the number and sizing of management servers to just handle the different workloads and also the ability to fail over certain workloads, we also see that when gateways are used, they're not considered well in their design and uses. This also comes back to understanding whether or not high availability is needed for gateways and how they tie to resource pools. Resource pools are also very misunderstood here. Resource pools, for example, distribute load. They don't eliminate the load. If every node in your resource pool is overloaded, then the pool just spreads the problem evenly and then crashes in the end. They might even be fragile to a failover. So what if a member fails? Do the rest getting the extra workload can actually handle the extra workload? Or do we get a domino effect of everything falling over? A health check replaces assumptions with facts, actual queue lengths, workload distribution, and capacity headroom. So this is the point in the story where we usually stop talking about SCOM feels slow and start talking about why it might feel slow. Now, in real environments, SQL is almost always the primary amplifier of problems. This is not because the DBA is unwilling or does not know what they are doing. In most cases, we can discuss very well with them. The key thing to understand is that SCOM does not tolerate variability very well. Small design shortcuts in SQL don't fail immediately, they just quietly accumulate impact.
Let's start with high availability. Many environments technically have SQL high availability, but it was implemented for uptime, not for performance stability. For example, synchronous mirroring or always on across high latency links introduce commit delays that directly affect OpsDB insert rates. From SCOM's perspective, SQL is always local. If commits slow down, everything slows down within SCOM. Another thing is disk layout, which is a recurring issue. We still see OpsDB data, logs, tempdb, data warehouse, and its logs and backups living on the same underlying storage. Even when separate loons exist, they often share the same storage tier. This leads to unpredictable I/O latency, and SCOM reacts badly to unpredictability. Keeping certain types of data separated through different disks and sizing them right can make a lot of difference. We regularly see disk latencies of the SQL data disks, leading to problems in the backend.
Yes, and also versioning matters more than most teams expect. Unsupported SQL versions don't always break immediately, but they often miss optimizations that SCOM relies on, especially around tempdb, query execution, and finally authentication. Windows authentication is the only supported mechanism here. SQL authentication introduces credential management risks and often correlates with legacy designs we see struggling the most. Because the default authentication method for SQL has been Windows authentication for a number of versions now. I think 2005 or 2008, somewhere around that time. However, we often see DBAs defaulting back to mixed authentication for some tool that they are using, for example, to manage the database assets. This makes it an unsupported backend for SCOM. So the goal isn't perfection, it's predictability. Once SQL behaves consistently, everything above it stabilizes surprisingly quickly. There are many optimizations you can do with SQL, and it's a big chapter in our health check document as well. For small SCOM environments, a negative effect might be small, but in bigger environments, it really helps to optimize the SQL backend behind the SCOM backend.
During our admin trainings, we always stress that in order for the monitoring components to talk to each other, we need two main things: connectivity and trust. Connectivity problems are particularly dangerous because they rarely look like failures. Instead, they look like instability. Firewalls are a common example. Ports might technically be open, but packet inspection, throttling, or asymmetric routing introduces latency, which SCOM is very sensitive to. Even a few hundreds of milliseconds of additional round trip time can trigger workflows retries, agent failovers, or gateway reconnections. For the SCOM backend system, such as SQL and the management servers, we expect the least latency, otherwise we will run into problems. If other locations come into play, this means we need to take it into account in the design and plan accordingly.
Right. And also, when we are talking about gateways, so gateway design plays a huge role here if other locations are involved. They are not always needed, and we only use them if we feel that we can get an extra value out of them. Gateways are often placed correctly from a security perspective, but not from a performance perspective. For example, we see gateways serving too many agents, or gateways connected over one links with unstable latency, and then blamed when the agents go gray behind it. Certificate authentication adds another layer of fragility if not managed properly and proactively. For example, expired certificates, mismatched trust chain, or forgotten renewals don't just cause a disconnect, they often cause partial failures that are harder to diagnose. Good connectivity design isn't just about security compliance, it's about predictable behavior under load. We often see configuration errors in connectivity and trust leading to unwanted behavior and leading regularly also to questions in forums that we lead back to the same things every time.
So we come to the latest part, I mean to the last part, which is agents. Agents are the edge of your monitoring environment and where technical depth tends to hide. We often see old operating system versions, outdated SCOM agents, or systems about to be decommissioned often stop receiving attention, but they continue generating noise and load. Multi-homed agents are powerful, but without a clear routing strategy, they introduce instability and uneven load.
Yeah, I think it was not that long ago when we still saw environments with Windows 2003 and Windows 2008 in it, and yeah, they were trying to still monitor it, but that also gives some other issues as well. We often see organizations wanting failover options for agents and gateways, but forgetting to actually configure any of it. Or high availability failover paths are often configured once and then never tested or adjusted when time goes by. Active Directory integration is one of those features that is only in use in maybe 1 out of 10 organizations at most. Sometimes we find that it is actually still turned on for agents without any configuration, or we have even found a few times that AD integration was turned on several SCOM versions and migrations ago. And of course, those servers don't exist anymore. The management group doesn't exist anymore. The information never got changed, so now agents try to multi-home themselves to a non-existing management group. It's just stuff that we can live without. APM is one of those components that is also used only in a few cases. Sometimes this is because somebody is not familiar with its possibilities, as goes with other features of SCOM sometimes. Sometimes it's because another tool is being used for APM purposes. That is fine. Application performance monitoring you can use in multiple ways. In cases where you are not using APM, you can clean up the management packs belonging to it to lower some of the risks and also keeping things clean. Also, we have mentioned here the OMS agent. We have also added that to the list because it was used for connectivity to the cloud. In the old days OMS, the Azure Monitor side of things, but this specific version is no longer supported and is no longer in use. If you find that you have a 10.20 version agent, you better replace those for SCOM 2022 or 2025 agents. Even if
Yeah,
you are still running SCOM 2019, you can better use that version than the OMS version. Ali?
just one thing I would like to remind is that if you are not using APM but using another APM option or application in your environment, we would advise to disable APM plugin because it might interfere with the profiling might interfere with the existing third-party product and can cause profiling problems for that application.
Good point. Good point. All right, versioning. Versioning issues rarely make environments explode, but they slowly erode the reliability. Most environments are not old, they are just inconsistent. Not because you want them to be, but because it simply is a fact of life. This is stuff that happens. The SCOM management group might be on a recent update rollup, but the gateways are 2 update rollups behind. Reporting services haven't been touched. Web consoles run different versions than the backend servers. We have gone to several customers where we were looking at the number of SCOM agent versions and Windows operating systems that they are running on, and found a high number of different versions. The same goes for SQL, where we find different year versions, cumulative update versions, languages, editions such as standard or enterprise, and so on. At some point, it looked like no 2 servers were the same. Remember that this is very difficult for any organization and IT team to support. We know it is difficult to standardize, but often when we show people the actual information of all the different versions that they are running, they would like to investigate coming back to less versions of everything to make things easier to support and connect.
Yes, that inconsistency leads to subtle bugs, unsupported scenarios, and wasted troubleshooting time. Forgotten components are the biggest offenders. Gateways, reporting servers, web consoles are often excluded from the patch cycles, yet they are critical user facing components. Consistent versioning drastically reduces complexity and uncertainty during incidents.
Okay, so now we've talked about all of the infrastructure components from design down to the smaller parts. Now, of course, we have to talk about manager packs, because manager packs are where the intent becomes the workload. Every discovery that runs, every rule that collects data, every monitor that evaluates state becomes processing somewhere in the system. We routinely find manager packs for technologies that no longer exist. Windows 2008 roles, retired applications, or obsolete infrastructure components. If you find colleagues running old stuff, please make it clear that it makes it difficult for backend systems to support, such as monitoring, backup, antivirus, policies, any other tooling, Windows updates. You can keep going. Old management packs can also create objects and monitoring that does not agree with the modern management packs. So, if you can get rid of old stuff because you no longer need it, that would be great. Sometimes we get rid of that with a side-by-side migration and making choices what to bring along or not into our new SCOM environment. We also often see unused management packs for products that you are no longer running in the organization. Even worse, we find management packs with failing discoveries where we know the products are still there in your environment, but they just refuse to be found, let's say, within the management packs. And that is not helpful either. These discoveries then fail continuously, generating errors, retries, and noise without anyone noticing.
Another, another common pattern is application upgrades without manager pack updates. Any version of Windows or SQL or random application is installed and configured, and nobody has looked at the management packs if they actually support that application for that version. The application changes, but the management doesn't. Suddenly, monitoring produces incorrect results, missing objects, or false alarms, and confidence drops. Regular management pack review is not an optional maintenance, it's operational hygiene. Often forgotten is to look at the management pack upgrades for the regular Microsoft management packs, but also third-party packs and those from the community. There used to be a few websites that got taken down that were very helpful. There are some tools and scripts out there that can help as well next to the options in the SCOM console. But the SCOM console needs connectivity to the internet to pull in a list of packs with versions.
Yeah, and some organizations have that closed off for good reason, but in that case, you need to do some manual checks or use tools to help you with these things. And they are there, of course. So overrides are one of SCOM's most powerful features and one of its biggest long-term risks. Often we run into organizations where one person in the group does not like alerts or does not understand them and simply turns everything off and tries to close all alerts without fixing anything. We have seen this in several instances. So we have also seen the opposite of somebody enabling every possible piece of monitoring they can find and sitting in front of a huge list of alerts that turns out to not even be too relevant. Too many overrides create unpredictability. Too few creates noise. But the real danger is unstructured overrides. We often find overrides stored in default or vendor management packs being undocumented and applied broadly to just make alerts stop.
Yes, that makes troubleshooting nearly impossible later. Proper override placement, naming conventions, and documentation turn overrides into assets instead of liabilities. Well-managed overrides reduce load, reduce noise, and increase trust simultaneously. There are tools and methods to create overrides without having to resort to a set of overrides different for every server you run. We have seen cases where this wild forest of overrides was leading to nobody knowing what exactly was monitored or not anymore. While we are on the topic of tuning and overrides, this brings us onto the next subject as well.
Aha, then this is the next subject. So this slide describes one of the biggest silent killers of SCOM environments. Too much performance data is being collected and never used. Too many events are collected and even less used. Frequent state changes, especially from Linux, SQL, VMware, and Active Directory management packs, rapidly inflate database size and I/O. Most teams underestimate how quickly this churn accumulates. We listed some common big users of data such as SQL, Linux, and VMware monitoring, often accumulating tens of millions of data points every day. Now, you might have a few dashboards open with maybe some graphs and performance counters, and perhaps you run a report every month for a few counters. But you are likely not looking at tens of millions of dots every day. And the same goes for events, which basically becomes a list of entries to manually scroll through. I have never seen anybody being successful in scrolling through a list containing millions of event entries in the SCOM console. The SCOM console would simply crash before it finishes loading. And the same goes for running a report with, 10,000 pages of entries. We need to consider what is needed and if something is really not used. After consideration, if it would be useful. Then we tune it down by turning some of those rules off, and for others we can adjust the interval from maybe every 5 minutes to every 20 minutes as an example. We have seen databases and data warehouses grow huge within a few days' time because of misconfigurations or not tuning at all.
And it's not the one that's suffering. The dashboards also suffer as a result. We mentioned here three other types of data in SCOM, which we define as config churn. They affect the backend of the SCOM and often also affect you. For example, by generating alerts, which might also be forwarded to ticketing systems and emails, but also dashboards changing colors to red, urging you to take actions. State changes, if they occur for no good reason, cause SCOM to have to calculate a lot and slow down. If they are valid or you need to take actions to fix something, do that first. Otherwise, alerts lose meaning and operators start ignoring monitoring. So reducing configuration churn almost always improves SQL performance, console responsiveness, and operator trust, all at the same time.
Yeah, I think this is one of the big things that we are seeing across the board. Also, mostly people don't even know where to look for this type of data. I mean, there are several queries where you can see how big some of the tables are, of course, but there are also reports available for this, which can show you simply how much data is collected and of what type, which monitors or rules are doing this. Well, the collection is usually the rules, but the state changes, they are the monitors, obviously. And you can actually go through it and figure out what is happening, not just by looking at the alerts or screens, but just looking at how this is all behaving. Because I think this is where the most gain can be made, to be honest. Most people are not aware of what is being collected, what is being monitored, and also where things are happening. For example, you might be looking at a dashboard during the day, which is maybe 8 hours of your day, but 16 hours of the day you are not looking at the dashboard. And you might find out that there are monitors switching back and forth between green, red, green, red, green, red, like the whole day long, um, without you even noticing it or noticing it well enough, let's say. This is causing Microsoft, the management servers, to be calculating and calculating and recalculating the whole day. And in some cases, this is actually not due to some monitoring mistake on the SCOM management pack side, which still does happen, let's be honest, but it's sometimes also, very often, because something is broken on that server. And if you're not fixing it, you are actually increasing the problem. So one of the first things that we often also say when we see a lot of state changes is, can you actually have a look at this or that server? Because we see a lot of mistakes, we see a lot of problems happening on that server. Some Windows services flipping back and forth, for example. And usually they will find out that this is the case and we can help them. I think also
And
one of the good examples is the Windows events. I think when something is crashing, we see
Mhm.
Windows events being collected,
Yeah,
and yeah, then we have to tell them something is wrong on the server, and they ask me, well, what are we looking for? So, well, just open the event viewer, and the first thing you will notice is, well, maybe that you cannot even log into the server. The second thing is that you notice that everything is red, so I don't need to tell you what to look for. Right, Ali? Have you seen that before?
yeah, we have seen that, and we have seen one of our customers that introduced a new event view collection rule,
Mm.
but in a wrong way. Actually, not without a proper testing, and they have realized that the OpsDB has increased to 500 gigabytes or even more in a very few days, which
Ooh.
just brought down the whole system, and it was really hard to get the grooming working, to get the database into a smaller size, and it took almost days to make it work in a proper way. You may even be surprised by using those reports, that built-in reports, on how much your SCOM is storing, how much data your SCOM is storing, and most of them is probably not used. And by tuning them, you can decrease the size of your database very in a huge amount, and which will in the end, as a result, uh, affect your performance, and you will start seeing more faster SCOM console, faster alert creation or grooming, and everything becoming much more faster. And even if you if they reflect to the also the operations manager data warehouse database, you will also start seeing faster reports being created. So data churn and config churn, all the, as you said, data churn and config churn are the things, the parts that we gain the performance most. Even though we have talked lots about the infrastructure and other things, this is the part we mostly gain the most performance. Or so, that's.
All right. So technology alone does not keep SCOM healthy. Operators need to understand what health actually represents. Admins need to understand monitors versus rules, targeting, class models, and stakeholders need dashboards that reflect business reality, not technical noise. We often see people in all stakeholder roles for SCOM, such as operators, admins, and people just working with dashboards, who do not understand how SCOM works and thus misinterpret things or look at the wrong screens. This sets you up for frustration. Most tools connected to SCOM understand how SCOM works, such as squared up dashboards. They use the same principles. If you understand how the basics of SCOM works at different levels, you also understand the output of those tools. We often find that adding a bit of SCOM training can help the teams forward in working with SCOM.
Yes, without that shared understanding, environments drift, overrides multiply, dashboards lose credibility, and SCOM becomes reactive instead of proactive. Training is not a one-off activity. It's part of the platform lifecycle. We have had people join our SCOM operator and administrator training after having worked with the product for a while and even years and discovering views and screens and ways of working with the basics of the product that nobody ever told them before, which I am one of them.
Yeah, there was one screen where you went, wait, what is this thing?
Yeah, because when you get
It's
used to
hidden.
working in a style, you just dismiss the other parts of the console, of the screen, or etc.
There you go.
But in a training, you see that these are the parts that I have never touched. For example, people go to alert view, but they don't even care about the state view. So that's one of the things that you learn during the trainings.
All right, let's go on with this one.
Yes, this is where monitoring either becomes actionable or irrelevant. Without idle processes, alerts states as alerts. Without automation, the same instance repeat. Without integration, SCOMS becomes a silo. And dashboards should answer questions for stakeholders, not just display health states.
So when SCOM integrates cleanly with incident management, automation, and business views, it regains its original purpose. We want to gain insights into how our machines are running, not for the sake of caring about one machine, but we want to know what is running on it and what application is this a part of. That way we can create monitoring related to how actual people see it. This set is running a website, that set is running a business process, and another set is running, for example, the email systems. This way we show what stakeholders need to see and understand. At that point, monitoring stops being a cost center and starts being a decision support platform. Having it connected with other systems and processes can help with this. Of course, it does not work well if SCOM is a total mess. We have been at customer locations where SCOM console was slow. I just happened to notice on the open screen on the wall, even before taking my coat off, that there were 10,000 alerts open. Well, luckily it was not connected to the ticketing system at that point. First get in control, next make it more effective, connect it to ITIL tooling, automate things, create dashboards for stakeholders that are useful. So this is where today's discussion connects directly to our fieldwork. We run these checks regularly, and in most cases the automated way of using a set of PowerShell scripts we built over the years pulls up a large part of the information that we need. And in rare occasions we need to do some more manual checks. When we are finished with the checks, we create a document with technical reasoning about the checks that we have found, and it also shows checks which were found to be okay. We ended up with about 60 to 70 pages usually, which we talk through with the technical people in a session of a few hours.
And our health checks combine deep technical analysis, practical recommendations, and management level reporting. So findings turn into action. We create a separate PowerPoint management presentation to talk through the main findings and define what we think are the next steps. This leads to either finding some issues and fixing them, or getting a great inventory of SCOM system before or after an upgrade or migration, to name a few reasons for running this. By the way, we currently have a special offer. If you order the SCOM health check before the end of May, you will get a discount. Just mention this session and don't forget to order it by the end of May. So this does not mean you have to run the health check already before that time. It's about us getting your code request just for the order.
That's it. So that brings us to the end of the session. We have done technical sessions before, talking about specific technical details here and there, which button to click. We are thinking of running a few of those again, by the way, with some refreshments on the content. Today we have chosen the current format because we first want to gain an overview of the main topics where things can go wrong and how we look at those, and mentioning a few on a more technical level. We only had 40 minutes, which I think we are at now. So Ali?
Yeah, if you take one message away, let it be this: follow the evidence and fix the biggest problems first. These steps work everywhere. When applied consistently, they restore performance, reliability, and the trust in SCOM. And you will be more happy in the end. So we would like to thank you for spending your time with us today.
Thank you. Bye bye.